I'll just briefly introduce what we have, how it works, and then I'll turn it to Vijay to talk about his experience with it, how the problems they had installing it, the solutions, and the paybacks. In any kind of refractory line unit, you want to be able to have protection against that refractory cracking. You know, typically in an SRU, you're running at like 1250 degrees C. The shell of the unit, when it hits about 320 C, you can have catastrophic results. Even API says that you need to monitor between the thermocouples. How do you do that with rain shields? Are you doing that? Is 2 thermocouples or 4 thermocouples enough to detect any kind of refractory failure? And so back in 2022, WIKA purchased a small company. And that's when I found this technology. And basically what it is, it's a 3-millimeter cable that only gives you the highest temperature anywhere along the cable. So people go, oh, it's a thermocouple because it has type K wires in it. No, there's no junction. So right now, I would read 400 C. We'll go back. But if I move this flame over, then you would see that temperature. All right, so it only reads the highest temperature anywhere along it. The way it works is that we have a secret powder inside. And as the temperature goes up, the resistance in this powder goes down. And so your voltage goes to where the least resistance is. The voltage, then it generates the voltage at that point, which correlates to the temperature at that point. So in a unit, we can divide it into zones. And then in a particular zone, let's take this red area. If you start to have a failure, we'll see that temperature go up. Now, you don't know if it's here or here, but at least you know you have a problem. And now you could come in and blow steam or something to get to your next turnaround. And then we come out, we install these, and I don't want to go into a lot of detail. I think Vijay will cover that. So with that, I think I'll turn it to you, Vijay.
So good morning. This is just a case study. In our SRU unit, refractory issues were there. We had some monitoring techniques, traditional monitoring techniques. There were some limitations with the techniques, and we found an innovation that is developed by WIKA, how that is more effective than the traditional method, and how we implement it. This session is all about these things. So previously we had failures like this. You can see in the first image, that is a perforation of the MCC cell. So this is the cross section of the refinery. So burning zone will be there. Then you will be having 3 layers of refractory. You will be having a bricks, then 2 layers of castable refractory. Refractory failures will come. Why? It is due to thermal loading or chemical attack. Chemical attack in the sense the H2S what we are processing that may condense, it may cause condensation corrosion. Mechanical stress also. The top 180 degree of the refractory area, it is most vulnerable because it is sitting against the gravity. So this zone only we have to focus more on the integrity point. We had one failure in 2022. In that time, you can see that image, this rupture image. The right images, so you can see that refractories were detached and the insulating castables were eroded. The anchors were oxidized. This is due to that hotspot failure issue. So the traditional methods are 2 methods. One, you can do point thermocouple measurement. If you're doing point thermocouple measurement, only you are covering particular point, not a particular area, particular point only you are measuring. Second, you can do thermography, but thermography also will come with some limitation. This is me performing that thermography. Every time you have to remove that shroud. Shroud will play some very good purpose for maintaining the integrity of refractory. 2024 same conference, one of our engineer came. He found that WIKA has developed this linear thermocouple technology. This is superior to these two methods, the point thermocouple and our thermography. So we divided our MCC into 3 zones where the maximum temperature can go. That 3 zones we have identified, and we installed this thermocouple. It is kind of point contact type thermocouple only. You have to mount on the shell. Then there will be a holder. That holder has to press that over the shell. That holder can be connected by these stud bolts. So this is the transmitter. After mounting this, we integrated with our DCS panel. Now it is in our DCS panel. Then we are having in-house IOW monitoring system, integrity operating window monitoring system. So whenever the temperature breaches the IOW limit, for this case the temperature is 343 degrees Celsius. So with the cushion we kept IOW at 320. Whenever it goes above 320, we will get an alert. Then we can take the corrective action. Why it is superior than the other two basic methods? The first method, point thermocouple, it will give you only 1 point reading. It won't cover the full area. With the linear thermocouple system, you can cover the very large area you can cover, and there is no need to remove the shroud system also. If suppose you are finding the abnormality, then you can open the shroud and you can verify. If you see for the cost perspective, every time when you are doing thermography, you have to remove the shroud, you have to erect scaffolding. That is an attributing cost. But this method, you can completely eliminate that. Or you are going with the traditional method, some uncovered area, blind spot you are leaving. This cost is a cascading cost, not like a single fixed cost. Suppose you are effectively not monitoring this area, you are leading to MCC rupture. Then you can't operate MCC. MCC is the mother equipment for sulphur recovery unit. If you are not running sulphur recovery unit, you are not able to run intermediate unit, you are not able to run primary unit also. Ultimately, you are supposed to shut down the full refinery. For our refinery, if you are not running the SR unit, it will be like per day loss of more than 165 crores. So that's it from my side.